there, it's Mrs. Lindquist. So let's take a look at example 4, solving each equation for all theta. So in example B, we have sine theta times cosine theta minus cosine theta equals 0. So this looks quite complicated, more complicated than the other ones we've been solving. So I'm not really sure what to do with this at the moment, but I do notice that both parts of the equation have a cosine theta. So I'm going to factor out cosine theta. So basically just doing a greatest common factor. So if we divide out cosine theta, we are going to be left with sine theta minus 1. Okay, so we have our equation now in factored form. So if you think about quadratics, once we get to factored form and we have two factors with the product being 0, we either know that the first factor has to be 0 or the second factor has to be 0. So one of the two factors has to be 0 in order for this product to be 0. So we're going to set each factor equal to 0. Okay, so let's take a look at this first one. Cosine theta equals 0. So where is cosine equal to 0? Cosine is our x. So we know that we're going to have an x value of 0 at 90 degrees, 0, 1, and also at 270, 0, negative 1. And they actually want these in radians. So we're going to go with radians. I know it doesn't say that, but most of the problems are going to want answers in radians. So this is going to be our half pi and 1.5 pi, which is 3 pi over 2. Okay, so for this one right here, we can say theta equals half pi and 3 pi over 2. And we'll worry about our coterminal angles a little later. So let's take a look at the second one here. Sine theta minus 1 equals 0. So we're going to solve this equation for sine theta by adding 1 to both sides. So we end up with sine theta equals 1. So where is our sine equal to 1? Remember, sine is y. It's right here. Our y value is equal to 1. So we're going to have pi over 2. And is there anywhere else on the unit circle where the y value is equal to 1? And I would say no, because the only other place we have is y is equal to negative 1. So this is the only location right here where the y value is equal to 1. Okay, so we are going to write down all of our coterminal angles. So we're going to have half pi plus all of its coterminal angles, adding or subtracting multiples of 2 pi, and then we're going to have 3 pi over 2 and all of its coterminal angles. And then again, we don't need to list this one because we already have it here. And so this is our solution. 3 pi over 2 and pi over 2, including all of their coterminal angles. Okay, so why don't you pause the video and see what you guys can do with example C, and then we will come back and talk about it. I want you to notice that this equation is already in factored form. It is a factor times another factor is equal to 0. So they've already factored it for us. So I would start off by setting both factors equal to 0 and going from there. Okay, so here we have our cosine theta being equal to 0. So we've come across this several times now. Our cosine of our x is equal to 0 at half pi. And also down here, our x value is equal to 0 at 1.5 pi or 3 pi over 2. So this one here was pretty easy. So let's take a look at the second part of this. So we're going to solve this for sine theta. So we're going to add square root of 2 to both sides. And we're going to divide both sides by 2. Okay, so where is our sine? Positive root 2 divided by 2. Remember, we know sine is going to be positive in the upper two quadrants if we think about all students take calculus. And it's going to be positive root 2 over 2 in this location and over here as well, because we are going up root 2 over 2. So we can see our sine, or our y value, is square root of 2 over 2 here and over on this side as well. So over here we have quarter pi, and then we have half pi, and then this would be 3/4 pi. So theta is going to equal quarter pi and 3/4 pi. So now we're going to take our take a moment to write out all of our solutions, adding in all the coterminal angles. And there you go, those are all of our solutions. Okay, so when we look at example D, we have 4 cosine squared theta minus 2 equals 0. So I'm going to solve this equation for cosine squared theta. So I'm going to add 2 to both sides, divide by 4. And now, to get rid of our squared, we're going to do our inverse of square rooting. Cosine theta equals, remember when we square root both sides of an equation, we have to have positive and negative. And we have the square root of 1, which is 1, over the square root of 2. So at this point, we need to rationalize our denominator. Multiply by root 2 over root 2. So we end up with cosine theta equals positive and negative square root of 2 over 2. So think about all students take calculus. Cosine is our x. So cosine is going to be positive in these two quadrants, 1 and 4. So we can see here we're going to be going to the right square root of 2 over 2 to get to this angle measure of quarter pi, and also to get to this angle measure of 7 pi over 4. So that's where the cosine is a positive root 2 over 2. But then don't forget, we also have to do negative root 2 over 2. So we're going to reflect that over to these two quadrants. So we can see if we go to the left, we're going to have negative root 2 divided by 2. So our cosine is going to be negative root 2 over 2 at 3 pi over 4 and 5 pi over 4. Again, if you think about this, we're splitting this into quarter pies. This is quarter pi 1. This is 1 pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, and that's 7 pi over 4. So we have all of our angle measures, and we're going to include all coterminal angles for each. And there you have it. Those are all the solutions for theta that will solve this equation. Well, that's a wrap. Have a great day, guys.